Okay. A couple of weeks ago, my family's pump pot plots, and we were looking to get a new one. We use it regularly, and when I came to the store, I came locally to the stores here, had a whole bunch of models, including ones that said on them that you can add water to them when you want it, which of course is great for us because in my family we use lots of hot water. So being able to add water on Yom Tov would be a great boon and would be very helpful. So I bought one, and then tried it out. You'll hear more about what we do to try it out to see if I can understand why you should be allowed to add water on Yom Tov. And I couldn't figure out why you could. I tried on a few different models, some of mine, some of other people's, and I still couldn't get it straight as to why that would be okay to add the water on Yom Tov. At which point, I asked the CRC if we could take some apart. So the two here we're going to talk about here, there are two here that I'm going to show you afterwards, that the CRC got so I could take apart. Unfortunately, they're never going to make hot water again. And then we dealt with these ones that are here, that are available locally, two basic models that are available locally. I'm going to explain to you details in a second. We also dealt with another model that's not available locally, a whole different type. And what we're here to talk about is what we saw and what we found, and about this question about whether you could add cold water to your urn on Yom Tov. Okay, so let's step back 20 years. It's about. For the past approximately 20 years, there have been people, particularly one manufacturer, who have been trying to make urns and what we call pump pots, in order you push down the top, or you push a button and it pumps the water out, try to make those especially for the Jewish community. What does that mean, an urn for the Jewish community? What does that mean? I mean, an urn is an urn, it makes hot water. So they have two special features, at least, two special features that are directed especially from people, and one is that some of them will come with a claim that you don't need to title this urn. You don't need to title it because it was made or owned by a Jewish person the whole time, and therefore it doesn't need to seal it, because you only have to title something that was owned by someone who was not Jewish and now came into possession of a Jew. Okay? Whether that claim is accurate or not, we're going to talk about when we get back to our regular Tfilas Kalim series. We're going to think about that and see whether that is or is not correct. There's a lot of different ways to do this, and we're going to get to that, whether that is, where that fits in. That's not for today. Okay? I forgot to mention. As part of our, okay, I'll mention it in a second. The second claim is what I mentioned before, which is that you could add water on Yom Tov. Okay? That's the second claim. That's a newer claim. That's more recent that people have been making that claim that you could add water on Yom Tov. Okay? So let me tell you a few simple rules of Yom Tov first. You probably know them already. Just some simple rules that we're going to be talking about before we move into the actual shadow we have. On Yom Tov, by and large on Yom Tov, a person can cook on Yom Tov. It's mutter to cook, and it's also mutter to make a flame bigger. Okay, if you're trying to cook and you want to make a flame bigger, that's okay. What you can't do on Yom Tov is you can't create something new. You can't create a new flame or a new anything. That's an isser pashtus. That's an isser d'rabbanan to make something new on Yom Tov. So in this context that we're talking about, red hot coil is treated like a flame. So if I have a coil and I want to, let's say I have a stovetop with a coil on it, and it's red hot, and I want to make it higher for my cooking, then I can do that, okay? Because I'm not making something new. If I want to take my coil that's off and I turn it on, well, then I just created something new. I just made a fire from what was not a fire, and that I'm not allowed to do. Okay. Also related to this is that we sort of take it as understood, but it's assumed that anything electrical, even if it's not in making a coil and a fire like that, is also ushered to start on Yom Tov. You know, if I have a fan on in my house, if I have a fan that's off and I want to turn it on, I can't turn it on Yom Tov. Okay? That's assumed you can't do it. All those things that I mentioned, when it's Yom Tov, discussion of Yom Tov, basically all those things are the Rabbanan. All those things that I just mentioned. Okay. Moiled, right? To create something correct. Correct.
So raising an electric coil can sometimes have different contexts, so that when you raise it, it turns up one.
I'm not into that those kinds because they're tendrily not.
Actually, that you're allowed to raise electric coils.
Okay, so
you meant to imply
as I said, if the coil is hot and you want to make it hotter, as a rule you can. Usually they do not have notches like that. What you're describing is that there's such a thing as electrical, like on a crock pot, that it'll have on some crock pots, it'll have a low and a high setting. Okay, when you switch it from low to high, you're really not moving it from. You're not moving it higher. You're switching off the low and on to high, like two different switches. Okay.
Even if it's a dial which you turn from 250 to 350, etc., Sometimes it can be behind the scenes. It's really doing the same thing.
But as a rule, it's not. Okay, as a rule,
Even if it's not, depending on like why exact electricity is us, is that making with it or not?
I'm not going to get into that. We're going to a little past that by later on, but we're not going to.
It's not. Electricity.
Okay, let's put that on time. You could believe it or not believe it. Okay, we're going to get to that a little. No, it's relevant. No, it's very relevant.
No, it's relevant. I thought we can't do anything electrical on Yom Tov.
Okay, it is relevant, but yes, it's assumed that you can turn the knobs, except when it's special like his.
Even though they're powered by electricity.
Yeah, powered electricity. That's a rule. Okay, a knob. Okay. Okay. Now, if it was Shabbos, and I wanted to add hot water, and I wanted to add, this is on. Okay, if I wanted to add, this one works. This one still works. This is ours. If I wanted to add water to this on Shabbos, there's an obvious reason why you can't do that, because you're now out of cook. Bishul is also on Shabbos, so if I add water to this on Shabbos, the water that is going to get cooked. So on Shabbos, it's obvious why I can't add water to this thing, because Bishul is also on Shabbos. That's easy. Of course, that issue doesn't apply to Yom Tov, because on Yom Tov, there's no issue on Bishul. Okay? But what we want to talk about is, when I put water into this on Yom Tov, does that make something go on? Am I turning on something electrical? Am I making a coil go on because am I adding the cold water? Okay? That's our question. When we had old-fashioned ones, the ones before they started making them special for frum people, it was pretty obvious that you shouldn't do it. If you put in the cold water, the thing goes on and starts cooking up the water, so the bishul is not the problem per se. The problem is that you're causing the machine to go on.
Wasn't it on already? Just we can go higher?
So as what happens is that in a regular one, when it hits the temperature, it turns off. When it gets to the temperature,
warm,
it's on and off.
What?
It's on and off.
No, it's on and off. When it hits, it's like your oven. When
you put it in, make it on.
If it is on, then it's assumed that it's okay. Well, no. Oh, first, okay. If you don't have toys like me in the second, usually you can tell. Okay, usually you can hear it. You stand next to it, you can hear it. The thing is on. You go downstairs to the urn, you'll hear it. I didn't bring that one up here. You can hear if it's on. If it's
no, once it gets that red light, you really don't hear it.
Okay, so I've stood next to it, and you can hear it.
That's only it goes out.
When it goes on, yeah, you can hear it go on and off. Yeah, we almost didn't have Dal meeting this year. In my house, the joke is that we're going to be shaking hot water urns for Sukkot, because I've been living in hot water urns for a few weeks. We actually have most of our meeting now. That's pretty good.
I think if it's on, you mean let that work.
If it's on, we will come to that later on as to why yet. Let's assume that if it's on, yes, you can hit water. Okay. So in the question we're going to talk about is, can I add water? Am I making it go on when I add that hot water on Yom Tov?
There's no keep warm setting?
On an old-fashioned one, like the one that's downstairs? No.
Because keep warm just means a thermostat cycling on and off, keeping at a certain temperature. That's all.
It doesn't mean that it's perpetually on a warm setting.
I'll play with the one downstairs after. We'll take the toy downstairs and you can see. I believe that I'm correct. Okay.
Well, let's give him a chance to see.
No, that's okay. That's good. Okay, that's fine. Okay. No. It's not that bad. Not that bad. Okay. So now, we're going to spend most of our time talking about these two over here, which are the ones that are available locally, which we believe have the more serious question. The one that's not available locally, which we brought into here to be able to try it out, which has the same claim that you could add water to it on Yom Tov.
They all claim you can
They all the ones that you see in front of you say you could add water on Yom Tov. And the new one that we brought in from out of town, that's not available locally. That one is even more bold about how it tells you can add water on Yom Tov. Okay.
It stresses cold water as well, or it makes.
That one says, that's even clear. You can add cold water on Yom Tov. And on that one, what it is like this. Okay, the one that we're not looking at, the one that's not here. Okay, I didn't have pictures for you. I have pictures, but not on the screen for you. That other one. It's a little more complicated than this. Complicated in the way the user gets to it. And on these, there's a switch that says Shabbos or Yom Tov, and it's on or off. Okay, it's easy to tell you if you're set up for Shabbos or you're not set up for Shabbos. On that one, you have to play with the buttons in a certain way. Okay, but the long and short is like this. On that one is there are two coils in the two ways of making the thing hot. There's a big one and a small one. Okay, the big one gives like 1,200 watts of power, and the small one gives, I think, 60 watts of power. I've got the numbers, okay? I don't have it in front of me. 90 watts of power, okay? And what happens is, when you set it for Yom Tov, to the Yom Tov mode, the way they want you to set it for Yom Tov, you set it for Yom Tov, only the low power coil runs. And it runs constantly. It doesn't stop. It never stops. And the higher coil, which is what's used to boil up the water, gives, 8 times as much, 1,200 watts of power. That one never, ever goes on. It just doesn't go on. So what happens is, the thing stays on low, gives a low amount of power constantly, straight. So you could add water, you could add ice to it, you could stick your shoes into it. It makes no difference. The thing is never going to change. Nothing's going to happen to the thing. It will just give its low amount of power forever. Okay, that's what's going to happen. It'll just keep on pumping out a low amount of power forever. Okay, so from the halachic perspective, it's no problem. Okay, there's no issue to bishul on Yom Tov. You can add water. There's no bishul problem. You're not doing a thing to electricity. It just keeps on pumping out the same amount of low amount of electricity, and that's all it does. Okay.
It stays on when you open the cap.
Nothing changes. You can do it. You can dance in front of it. You can do whatever you want to. Nothing changes. It just gives out this low amount of power. Okay. So from a halachic perspective, the other one, in fact, is honest. It's accurate that you can add cold water to whatever you want to it. Okay. Now, from a practical perspective, it's not as good because it can only give, depending on when I measured it, 10 to 20 degrees of increase of temperature an hour. Okay, it depends how much water is in there and all kinds of things, but 10 to 20 degrees of temperature of hour. So what happens is if I put in water, if we drink our coffees in the morning and now we're running out of water, we add the water in, we're not going to have hot water for hours. Okay, because it only gives you this much water. So if the water, if I refill it and now it's 130 degrees, in an hour from now it's going to be 140, 150, 160. It'll slowly warm up. That by the time it comes late in the afternoon, we're going to have hot water again. Okay, so the intelligent, if you're using it, the intelligent way to use it is to fill up before you go to sleep. Okay, because it takes forever to heat this thing up. It's running.
Max that it reaches?
The max that it reaches? Okay, so this actually, this is a very, okay, good. Rega. So it's actually bring up a good point, which for the Kashrus people, it's worth it mentioning. It's not so much to get to the Shabbos part of it, to the Yom Tov part of it, but it's to get to the Kashrus people in general. And that is, well, if it keeps on giving low power, why doesn't it just explode eventually? I mean, eventually the whole thing should boil. What's going to happen?
Oil, steam up, and all kinds of problems.
So there's a little bit of a vent. There's a little bit. Okay, so
and then all the water will steam out, and then the thing will burn.
So that was take a leak. Okay, so wait a second. Every day, Rega, every day it's at a boil. Okay, it's close to a boiling temperature. Okay, it runs at about 210 degrees.
10 hours to get that boil.
No. On a regular weekday, on a Tuesday afternoon, it's a 210 degrees. And now the whole night it stays on low also. It stays on low always. It's always pumping out this low power. So when you go to sleep at night, you should wake up in the morning with no water, or with it boiled out, or with it exploded, however you want. Okay, so the truth is like this. Okay, the truth is like this. There's another question, which is like this. When you put in the water, okay, the measurements were like this. If you put in the water that's in there is hot, and you put in cold water on top of it. When you mix the water together, it does not come out to the average of those two temperatures. It doesn't come out. If the water hits out with 210 and the water that you was 70, and you make the math, it doesn't come out to that average. It comes out higher than what you would have expected it to come out. Okay? And the reason is this is a Kashrus thing you should just know, which is like this. When you boil water, when you raise water temperature from freezing to 212, from 32 to 212 degrees, it's called sensible heat. Every BTU you add in raises 1 pound of water 1 degree Fahrenheit. Okay? 32, 33, 34, 35, 36, keeps going 1 pound. When you get to 212 degrees, so the logic says is, if you add 1 more degree, it's all going to boil. It'll go from 212 to 213. Boom, the water's going to boil. That's not the truth. Okay? There's something called latent heat. Okay? You add, I believe it's another, I'll put my papers here, 970, 920, I've got the number. BTUs have to be added to get the water from being 212 degrees water to 212 degrees steam. Okay? You have to add it. It's called latent heat because in Hebrew we say it's bekaya. You just keep pumping in heat into it, and the heat doesn't make any difference. It doesn't change anything. But that heat is all being absorbed, and eventually that heat's going to, when it gets to 212, enough BTUs, it'll actually boil.
So it stays at 212?
It stays at 212. It just sits there at 212. It stays there at 212, and the heat just keeps on pumping into another, almost 1,000 degrees worth of heat gets pumped into it.
Where's it go?
And it's just sitting in there. It's waiting to come out. It's like tightening up a coil, like a spring. And what happens is, and that's the reason, the Kashrus reason, that's the reason why it's so much more efficient to cook with steam, because that latent heat very easily comes out. So if you have steam running around the plant, then what happens is, when that steam hits your ketchup, you're not cooking with steam that's 212 degrees. You're cooking with steam that's essentially 1,000 degrees. Where you're cooking with 212 degrees of actual temperature and another 900 and whatever degrees of latent heat all hitting your ketchup.
So you can only feel 212.
And when it hits the ketchup, no, the ketchup feels 1,000 degrees. And the latent heat actually the steam, the latent heat transfers much faster than the sensible heat. It transfers instantly. So when your steam hits your ketchup, all of a sudden 970 whatever degrees pump into your ketchup. heating up your ketchup much better, and then the steam turns into water and drips out the box.
What's the temperature of the steam?
212. On a thermometer, it's 212. But how much energy does it have? More than 1,000 degrees worth of energy.
If someone gets a burn,
On steam is much worse than anything
equivalent of 2,000.
Right, of 1,000. So what happens? So what's going on here is that overnight, or as it sits, it might be sitting at about 212 degrees, but it's absorbing more and more and more energy. It doesn't have to boil. So there's vapor coming out because of evaporation. There are vapors coming out of it, but it's just absorbing more and more heat, and it just stays there. It could stay there for, I don't know, I didn't calculate it, but for a month before it's going to really come to a boil, okay? And what happens is, when I said to you, I added a lot of cold water to some hot water, that latent energy was transferring into the cold water, so the water ended up being hotter than you would have expected it to be, okay, than the average would have expected it to be. Okay? So I'm sorry, that was a digression.
So yes, the question is, then at some point you'll have a problem, but it's not enough.
By that time, we'll all be grandmothers. I mean, it's going to take forever until that happens, right? That's like, so
it's over for sure.
Yeah. I didn't make the Kashrus. How long it takes? It takes forever, okay? So that's not, I'm not worried, that's not the problem, okay? Anyhow, back to where we are, okay? So that one, back to where we were, that one that we don't have locally, has no problem adding water to the Yom Tov. If you set it correctly, you have to set the numbers correctly. I forgot to tell you, when you set the switches correctly, the light is disabled also. And you're allowed to add water to the Yom Tov. You have to do it smartly, just so you want to have hot water, but you can add water.
Brand names or
I'd rather not.
Okay.
On this, I'll tell you afterwards if you want.
You tested this one. This other one that's not available here.
Yeah, I did. I tested it. I unfortunately, I didn't have the fun again to take it apart. I couldn't find the justification of taking it apart. I had much too much fun taking these apart, but I wanted to. But after we did it, I still continued to play with it at home. So it's not broken yet. Okay. Anyhow. Okay. Now the ones that we have here, the ones over here, the ones that you are available locally, they work almost exactly the same way. Okay, I'm going to tell you a very significant difference in a few minutes, but for the beginnings, they work the same way, and that is this. Okay, this is my crude diagram of how they work. Okay, in this picture. Okay,
like the water.
In this picture. Okay, you see here. Okay, there's an electric coil. Okay, and electricity coming in the picture, it's coming in on a blue line. Okay, electricity is coming in from the wall, and the electricity that comes in from the wall goes straight to the coil. Okay, essentially, it goes a straight line to the coil, and it goes out, and what in our picture is gray, out to the gray line, out the other side. Okay, so when you plug your machine in, it just goes and just runs. That's a low amount of power that's running in from what I call line A. Okay, doesn't have a name. I call it line A. Some of them call it a primary line. Okay, it runs in and gives heat to it. There's essentially no control on that line. The only control is if you want this, or if you want to see this over here, this is what we call fail-safe, and this is a control that says like this. If it gets super hot, it cuts electricity to the whole machine. Okay, that's really there to prevent it in case you run out of water. So that it'll keep on pumping out heat. There'll be nothing measuring the temperature. So this is glued on the side. Okay, this one is glued in over here on the side. And it just sits there. Okay, this is like a fail-safe. That's not that, but that's the only control that is. This is on the return line in this machine. This is.
You mean if the return line comes the same amount going in?
It's an electric circuit. So if it breaks someplace, the whole circuit dies. So this is on the return line, and this says if it's super hot, meaning there's no water inside it, that's what happens. If there's no water, just keep on pumping out heat with no water, then it just closes down the whole machine. Okay, so that's the only control. But basically, besides that, in case of emergencies, aside from that, the electricity flows in what we call line A, the primary line, and just pumps out a small amount of electricity into the machine. Okay, at the same time, that electricity, that line coming in our case is blue, branches off through what we have a black wire. They're not black over here, but it branches off to the control box. Okay, that's this stuff over here. Okay, and the other one, same thing. It branches up into a control box. And from there, a different colored wire comes to the coil, to the electric coil, what we call line B, comes into the coil. That line B is controlled. That line B doesn't just flow, it goes through the control box. And the control box has, I'll show you on this one, a temperature sensor. This is a temperature sensor, and there's one of the same one over there, also similar, a temperature sensor, and the temperature sensor sits on the bottom of the pot. In this case, it sits on the bottom of the pot, and it measures the temperature. Okay, and it's feeding back to the control box
20 minutes. doesn't say
It's feeding back to it. It feeds back to the control box what the temperature is, and depending on the temperature, line B goes on or off. Okay, that means is if let's say the number is that they're looking for is goes on at 200 and off at 210. Let's say it's the numbers. So if it says it's under 200, the switch goes on and says line B go on. Okay, if it's over 210, it switches it off and it goes off. Okay, so line A is always flowing, and line B is controlled by the control box. That's what's going on.
It gives increased electricity to the same coil.
Say it again?
Then it gives more electricity to the same coil.
I'm going to talk about the coils in a second. I'm not talking about the coil. For now, there's just coil. Okay, just pretend that there's coil. Okay, so they basically all wrong like this. So what's going on here? There's always electricity flowing through what we call line A through into the coil, and there is sometimes electricity flowing through line B. Got that so far? Okay, what's my pretty picture? Okay. Now, the difference between the two units is the two units are made very differently from one another. Okay, even though to us they look roughly the same, they're very different. Okay, and one is the what we call a pump pot. Okay, that you either pump or you push the button, and that one. Here's the coil for that machine. This is the coil. Okay, this thing here is the coil. It wraps around the bottom of the pump pot. It wraps around the bottom here. It will go around here. The coil, this big metal band that you see here that looks like a coil, actually, this is just the outside cover. Okay? What goes on inside is, I'm going to show you on the picture. The picture's not great. What goes on inside is that there are really 5 layers of what I call cardboard. I don't know if that's what it is. Essentially, a cardboard on the inside. Those are 5 layers that are 3 layers of insulation, sandwiching 2 other layers that are the coil. Okay, so it's 1, 3, and 5 are nothing; they're just pieces of cardboard, and 2 and 4 are the coil.
Cardboard? It only catch fire?
It's just I don't know what it's called. It's not cardboard. I'm calling it cardboard. I don't know if it's cardboard. It depends what it is. It's essentially cardboard. Okay, but it's not important to me what it is. But what's in between 2 and 4, that's the coil. Okay, well, when you look at it more carefully, you find out. Let's see the picture. I don't know how clear the picture is. It's not so clear. Look on the left side. Okay, what goes on. This is one wire coming in. This is the other wire coming in. One of these is A, one of them is B. If you could see it here, it's hard to tell. You can look afterwards on the thing itself. This one is attached to this coil. You see this? This is the wire goes till here, and that one goes through the hole and goes down to this one. Okay, you can't see that part of it in the picture, but it goes through. It's not attached, and it goes through till attached over here. This one is attached over here. I have other pictures on the underside. You can see how it attaches onto it. Okay? So what's going on here? You can look at it afterwards. Maybe we'll be able to see it better. So what's going on here is that in this big thing that we call a coil, there are actually 2 coils inside of there. Okay, and if you look on the outside of the machine, it says 120 volts, 750 watts, 43 watts. Okay, Mapitom, 750 watts and 43 watts. What does that mean? That means that one coil is 750, one coil is 43. And voila, when we measure, this is measures electricity flow, and when we measure electricity flowing through, when the temperature is at a boil, we get 45 watts going through. Okay, when it was not boiling, when it was boiling itself, when it needed to boil, voila, 768 watts. Okay, was that not 678 watts. Okay, so it flows through exactly like it says in the machine, how much it can handle each of those coils. And the coils are not. This coil is actually it's what I call cardboard with a wire wrapped around it. Okay, and one of them holds a lot, one holds a little. So line A, there are really 2 coils. If there are 2 coils, that means is when I put the water into the machine and I get it to go on, I'm not, even though there was always electricity going through it, I'm not making more electricity. I'm not saying, there was a little bit and now there's a lot of electricity. There used to be coil number 1 was on, and now coil number 2 is on. They have nothing to do with each other except that they're wrapped in the same piece of metal. But on the etzem, they're 2 different coils. They could be in 2 different rooms for all we care. Okay? So when I put in the cold water, what makes it go on, I'm making go on a second coil. I'm not making more electricity to the same coil like in our stovetop. Okay? I'm not have 1 coil. I really have 2 coils, and I'm just making the second one go on. The first one always stays on. Okay? If you remember in the previous picture, line. Does that work? I don't know if it works. Line A always pumps out electricity, but in the pump pot ones, line B is a completely separate coil. Now it's wrapped in the same outer casing, but really it's 2 different coils. Okay, so when you get the electricity to come out to boil, you're actually turning on a brand new coil. Okay, so seemingly.
The fact that it's encased in one thing doesn't make you
No, because the truth is the truth. I mean, if you look inside of it, it's two different coils.
The metals is giving heat to the...
No. This is just protection.
It gets hot though. So.
It gets hot, right? So the water also gets hot. What's getting on here is that the wire, in one of these, the wire wrapped around is turning red hot, and then the other one's turning hot.
My point is that, in essence, you're changing heat, you're changing the level of heat to the outside.
Yeah, but you're turning on a coil. There used to be no coil on. Now there is a coil on. It's as if, imagine if we had a light fixture.
It's like if you have let's say you have a wood burning oven, right? And you had it set up so that when, let's say you have a candle in there, right? The candle goes down and that will light the other wood, right? So you have two different heat sources, but really it's all going on.
So you're spreading the fire from one side to the other side. That's okay. You're allowed to do it. You're allowed to spread the fire from one piece of wood to another piece of wood. But it's not spreading from one to the other.
It's not one coil like the other coil there.
I know, I'm saying that why you look at the outer rim as the heat source.
Because it's not. It's just a piece of metal. It would never get hot.
Separately.
What?
You can really take it apart and have
Right. The way I look at it, imagine we had a light fixture, okay, and it was covered, okay, and we couldn't see what was behind it, and there were two bulbs in there, and one's turning on the left bulb, and one's on the right bulb, so there's two different bulbs. Turning on one, more light comes out of the fixture, but the fixture is just nothing. The fixture doesn't make it.
They're both just heating up there.
They're not heating anything. No, they're heating themselves. Whatever's near them gets hot.
You're not heating up the water with that, heating the water with the outside rim.
I'm not talking about heating water. I'm talking about making water. Okay, let's move on. Wait, now. So in this one, in the pump pot, it's pretty straightforward. When you put it in the water, you're making the coil go on. Make the new coil go on. Okay, now, the urn is made differently. Okay, the urn.
So this one again was which one?
The pump pot,
Which is which one?
This.
That one.
That's the same thing?
This is that. It's the same thing. Yeah, this is just, actually this is a smaller version, but it's the same way of making it. And this one works and that one doesn't. Okay, now, I can't go to my next slide. Okay, now, the urn is not built that way.
Urn is the guy downstairs.
Is that
No, this is the urn. Okay, the urn, when I call it urn, means one that has a spigot on the outside. I should have explained it. Okay, a pump pot, you have to pump the water comes out of the top. You pump it to get the water out of the top. It's got a motor, or you could push it with your hands. The urn, you open up a spigot, and the water just flows out with gravity out of the bottom. Okay, that difference is not what makes the difference here. It just has to do with the manufacturing style. Okay, in this one, the same thing happens. Okay, in this one, in the picture, this white wire over here, that's line A, what I call line A. Okay, that's the low flow electricity all the time. And this one is the red wire, that's line, what we call line B, that's the higher amount of heat. Okay, and this ring going around, that's the coil. Okay, so
is it light usually neutral?
Don't ask questions. Okay, different colors, but both ones, they have their own ways of making colors. Okay, it's not.
I like the red, white, and blue.
Okay, yes, they both have red, white, and blue. They're both very patriotic. Yes, Chinese patriots. So the in this case is one coil. Okay, in this case it's just one coil, and with it, there's always it's the same setup that Exxon, which is there's always a small amount of electricity going through, and there's sometimes a lot of electricity going through. But in this case, the electricity goes through the same coil. Okay, so in this case, we're already starting off a step ahead. When I increase and make more electricity come through, I'm making more electricity come through the same coil. Okay, so now we have to think.
It's a new circuit.
Now we have to think about two steps about that. I'm coming to that. We're thinking about two steps over here. The first is like this: this coil over here. What you see is the gray. Well, you can see it on here. Okay, you can see it for real. Okay, this gray over here. This gray is the control. Look at the picture for curiosity. This is the temperature sensor, and this is what we call a fail-safe. This is the, oh my gosh, it's way too hot, we have to turn the machine on. Okay, that's the temperature sensor. Anyhow, you can see it later in the real one. So the coil is covered with some kind of a protective coating. So we couldn't see yet when it turns red hot. Okay? And when it turns red hot, it makes a difference to us because of the following. Mishmur brings, the way Mishlam Zaman explains it, like this. If you have something that's hot, just a hot piece of metal, and I put a match next to it on Yom Tov, and the match bursts into flame, that's considered you making a new fire on Yom Tov. There was no fire before. There was heat, but there was no fire, and the match is a fire, so I've created something new. I took heat and turned it into fire. What happens if I have a red-hot coil, and I put a match next to it? That is not considered to make a new fire on Yom Tov. Because the red-hot coil, as I mentioned, is considered to be a fire. So you're just extending the fire from the coil to the match. But if it went from red-hot to fire, that's the same thing. Not red-hot, just hot to fire, that's two different things. But red-hot to match is considered a new thing. So now, in the coil, our first thing we have to understand is, which I don't yet know yet, we haven't played around that much with it yet, one of my technicians has not been available, is when does the coil turn red hot? Okay? At low heat, is it red? I can only imagine that at the high amount of heat it's red hot. Like think about your toaster. I mean, you can only imagine that at the high heat it's hot. You can't see it until we scrape off some of that and then run the electricity with the thing exposed, and that I need my friends for that. At high, you can only imagine that it's red hot. On low, it's not. I don't know whether it is or is not red hot. Now, if it's on low, it is not red hot, and on high, it is red hot. Then turning on to high is just as it is with the other machine. Because then, what?
Is that what gets that?
To what I just said? I don't know. I think so.
No, to the coil, the status of the coil.
The status of the coil that what?
Between hot and
Not red and not red hot. The Shulchan and the Mishnah talks about it a little bit. Shulchan Shabbos explains it a certain way. Maybe others disagree with that. That could be others disagree with that. I don't know. I'm taking it from the way they said it. So if it goes from not red hot on low to red hot on high, then we have the same kind of a problem. You're turning a non-fire into a fire. Okay?
The equivalent of putting a block on a fire and making it red hot.
If that would happen, it would go from not red hot to red hot. Okay? Well, it's on top of a fire. We have a fire. We don't have to worry about making new fires because that thing is just an extension of this fire. You're allowed to do that. If this would go from not red to red, then we would have this issue. But it may well be that even on low, it's red also. Okay, I have to try it.
I get the basic difference between the two.
Okay.
This second one here, you're adding electricity to the same coil?
Yes.
Adding more electricity to the same coil?
Yes. Yes.
Is that partial that's mutter?
So,
You're making a new circuit?
I'm coming to the circuit in a second. Pause that a second. I'm not done yet. Right now, I'm just thinking that, am I making a new fire? Am I making a new fire? So, over here, if it goes from not red hot to red hot, I'm making a fire. If it goes from a little red to more red, well, that should be okay. But we won't know the answer to that question until we test it more to see when it changes from not red to red. Okay? But
people at electric stoves, when they want like Shabbos candles, they would use the flame.
so if they do it from red,
No, I've never heard of the chiluk of.
okay, so if you look at Shmir Shabbos, you talk about it. Okay?
It's not the Mishabur, it's Shmir Shabbos.
The Mishabur talks about, in the Mishabur talks about lighting a match from a piece of metal. And it says you shouldn't do it because you're making a new fire. And Rishon, he says not to do it. And Rishon Zalman says, whoa, wait a second. He says, wait a second, but
I don't know if it's musical.
the Shmir Shabbos is being made. He's saying that's only talking about when it's not red hot. But if it is red hot, then you're allowed to because then it's fire to fire.
It's a portion where you can't light a fire.
A match from a piece of hot metal.
Non-red hot metal.
Right. No, he doesn't even talk about red or not. Right. The Shmir Shabbos is so to speak being made. He's explaining. The Shmir Shabbos is explaining that. Okay, the Shmir Shabbos is explaining that what the Mishnah talks about is talking about a thing that's not red hot yet. But if it's red hot, then it's already a fire. Then you're allowed to. Okay, now, but what people have been grumbling about this year is, and that there's a more serious issue, which is. Forget about whether it becomes red hot. Let's ignore, okay, it's one coil, and potentially it's going from red to red, and it's not a problem, not making a new fire. Moscow. It's not less, but then turning on a fan. But what I'm doing is, line A was running, and I just turned on line B. I just opened up that circuit and created line B. That used to be doing nothing. Now, through my control box, I've turned on line B, which does whatever it does. Okay, now, in order to answer that question, is that mutter also, we have to correct into exactly why it's not allowed to use electricity. And the Kashrus says you would not be allowed to do that. That's enough turning on a circuit. Again, forget about what you're turning on as a coil. Okay, forget about whether the coil is red hot, the making fire shaboy, which we can ignore. We could say maybe it goes from red to red. But from the fact that you're turning on a new circuit, that seemingly should be also because that's what you're doing. Okay,
you can say it's a Grama.
I'm coming to Grama in a second.
And B, it's the same. The outcome is the same. It's negligible because it's the same coil. So nothing new is happening. That's not like a fan which is going from off to on. Here it's the same coil which is getting hotter.
So you're saying my circuit that I created didn't have
electricity not going through this wire. Maybe that's not considered a mice.
So my doing something that's so sort of in the background. Okay, that's a fair point. Okay, I don't think that people agree with that, but that's a fair point. Maybe you say is since it's on one coil anyhow. It's one coil anyhow, so the fact that there's more electricity flowing through, in this case, the red wire instead of the white wire, that's not just a serious thing. Maybe. I would wonder whether you call it negligible when you could see the coils can get much hotter. It goes from this to this. I'm not sure if that's what we call that negligible. Because it's not like there's something happening mysteriously in the back of a computer someplace. It has a very clear effect. If you put your hand onto it, it'll go from this hot to this hot.
You're saying that's more time at going from low to high in a fan.
That is what it's doing. Yeah. Okay, but maybe that's the point. Okay, now, the other angle to this thing is, which I haven't talked about, is that people wanted to suggest that maybe this whole thing of adding water, which let's say it would be ushered to turn all these things on as I've been describing, well, maybe I'm only being goyim for that thing to go, well, that to happen. I didn't do this directly, I did it indirectly. Okay? Now, there's two pieces of information that we're going to pass by really quickly. Okay, and that is about creating a grama. One is, there's a big to-do as to whether it's mutter or usher to create a grama on Yom Tov. Okay? There's a question about how to read a Ramah, whether Ramah means it to be allowing you to make a grama on Yom Tov, even if it's not a tzarech couple. Okay? It's a question whether he does or doesn't mean it. Many are makel to say that you're allowed to make a grama, to do malacha big grama on Yom Tov, even without a big tzarech. Okay? Let's assume, like the Mikkim, this whole discussion is going to make that assumption that it's okay to be, yeah.
How much longer does?
I don't know. A few more minutes. I'm almost done.
You don't have to step out using the screen now?
No. So this is all, we'll work with the assumption that making a grama yontif is mutter. Again, by no means is that partial. Many people say that it is. This is not today's discussion. Let's make an assumption that making a grama is mutter. You read the footnotes if you want. Okay. Well, that's one assumption. The second is, there's a shaila, the Bir Halacha says, what happens if I do a grama that it will, for sure, that what I did will cause other thing to happen. I did A, and it's a grama that B will happen, but it always happens. It happens every single time. Okay? The Bir Halacha says that's okay. That doesn't take it away from being a grama. It's true it will always happen, but it's still indirect, and assuming, like I said, the first thing, that you'll have to grama on Yom Tov, that would be mutter. Okay? That's what the Bir Halacha says. Reb Chaim Ozer says not like that. He says, no, if it happens every time, that's not grama. Okay? So in order to continue with this discussion, we have to say again, we have to say like the Bir Halacha, which is fine, I don't feel bad about that, that even though it's going to happen every time, that's okay, that's still considered grama. Okay? So with those two introductions, okay, so is it possible that what putting in the water is just a grama? So, as you probably remember, when there was a question about the...
Would this be the same child as opening the refrigerator?
When I finish, you'll probably know the answer to that question. Okay? Okay. When we had a question about Shabbos mode ovens, if you could adjust them, many of the questions that we're talking about are related to that, like the questions of pushing buttons and things like that. We're not talking about that. But one of the questions there is that what happens if I do something and the result of what I did is that a certain amount of time later, something else happens. I push the button, in that case, I push the button on my oven, and 30 seconds later, the oven goes up in temperature, or goes down in temperature, or whatever I was trying to do that. Okay? Is that considered to be a grama? And over there, the argument is that if I do something with a specific goal in mind, the fact that it takes a few seconds to get there, that's not considered grama. Grama is only when it's separated and not direct for what I'm doing. Okay? So if you remember, we talked about this, not about ovens. We talked about it. We talked about pastrol. That the question was, if I turn on a boiler, I push the button to make the boiler go on. When you push that button, the boiler doesn't go on. That's not what happens. When you push the button, the boiler sucks the air out of the machine. It tests this thing and that thing and the other thing. There's all kinds of things that it does, and then 30 seconds later, the boiler goes on. Okay, that's what happens. If you push the button, it doesn't go on. It's not like turning on a light switch. It goes through all kinds of checks and does all kinds of things, and then it goes on. So the question was, well, the Gemara says that if you have if you pull away a dam and someone gets killed by the water flowing out of there, you're only chayav if it happens in koach rishon. This is not a koach rishon. When I push the button, it doesn't automatically turn it on. When I push the button, it goes through a whole bunch of things, and then 30 seconds later it goes on. So you wouldn't be chayav for killing someone like that. So the question is that considered a pas Yisrael, Bishul Yisrael, by pushing that button? And the answer was, if you remember, there were a number of answers, but one of them was, Rav Shachta said from Reb Chaim, that by certain dinim, Ritzicha, there are two other ones, I don't remember them offhand. By three dinim, there's a din that you have to have a koach. What was his word? I forgot the word. You have to have, the person has to do with a koach rishon. He had a better word for that. Everything else, for all the dinim HaTorah, it's enough that a koach adam. I did something that caused that thing to happen is considered that I did it. Okay? So, over here, the fact that it takes it's a little removed in itself, that may not be it. But people say this way, if it takes a couple of seconds, okay, there are those who thought that if it takes a couple of seconds for it to happen, then it's considered, I have one more slide. I have another slide. That's considered to be grama. And the people who built it said to us, yeah, we built it with a pause. Okay?
The oven.
No, who built these? The pump pot said, No, we built it in on purpose that after you add the cold water, it doesn't turn on immediately. Okay? We made it on purpose that it doesn't turn on immediately. I said, really? Now, I have a video of it, okay, but we're going to do it live, okay, if you're curious. I have a video of it also, okay? Does it happen immediately or not? Okay, so I don't know, if one of you guys look at this, just, okay, this is measuring the watts on this machine, okay? This is measuring, someone's got to watch it. Okay? On the video, it's easier because I can slow it down and you can watch it in real time, okay? This is on, there's hot water here, okay, and and this is regular water, this is tap water, okay? So, if you watch the numbers, right now it's at 47 watts are going through.
You need someone to record it?
It's recorded.
Oh, the actual number?
No, you're not going to see that yet. And I have a video of it yet. Okay, you want to be good? Okay,
That's not it.
Okay, you see the number, okay?
I'm here.
Okay, I'm going to pour in the water. I'm going to pour in the water. It's at 47, okay? When it goes on, it'll be obvious. I don't remember what the number gets up to, okay? It'll be obvious when it goes on, okay? Ready? You guys watching? Okay. Okay, so in this one, actually, it took longer than I would have expected. Okay, it was, by the time I finished pouring the water, it was on already. Okay, and you can see the light now if you were looking at this also. If you want to be less techy than that, by the time I finished pouring the water, it was on. When we measured it we videoed it with I'll show you another one in a second. We videoed it with a stopwatch next to it, and then we did it in slow motion to check it. It took about 3 seconds. Okay, so we. With Rabbi Reese.
3 seconds to...
From the time water started pouring in.
What is the mechanism they claim makes this delay? Let him answer.
I think it's just part of the control board that just tells it, don't do it right away. It just pauses itself. So, Rabbi Reese was like, no. That's not, doesn't. I mean, I'm telling you, as you're pouring the water, it was already getting it on.
It wasn't until the thing was open.
So they can adjust it. Put a couple more seconds.
I didn't say. Now, once you mention it, I'll say, they are working, that the Pesach models that are coming out, things will be changed, things will be advanced. They actually have, we've been working, giving them suggestions, and they have their own ideas of how to make it better. Making the long delay is part of it. They have a much better idea than that. The current plan now is a much better idea of how to make it that it shouldn't have a problem. I can tell you that we're not recording. Trade secret. But they have plans for better. The question is for right now, okay? So, Rabbi Reese didn't think that was a Grama. And
because
neither did what we're told the Rabbanim and the Poskim that they're counting on didn't think it was either. Actually, the people who they're counting on actually told them, no, we don't get cold water. So it's possible. It is possible for it to be. Now, I want to show you in the other brand, the brand that I told you that we don't have locally. Okay, this is that urn. This is that urn. I hope that this works. Okay, we're adding water to it, okay? So what you see over here is this is my meter over here. Okay, this is watching electricity. It's 92 now, okay? And this is a stopwatch. Okay, the stopwatch is going to start before the water starts pouring in, just because we only have that many hands, and we're calling you that coordinate, okay? Here, watch on this one. Okay, now this one, I told you beforehand, you can add hot water even regardless of whether there was a delay. Okay, that's not in this case. It's not on a special setup for Shabbos. This is a regular weekday. It's a setup regular for weekday. They don't need the delay. But let's look at their delay. Okay. Does it work? Quick time not available. Okay, it doesn't work. Okay. You can come down and sit afterwards and watch it. In this, I don't know why it doesn't work. Sorry about that. Quick time not available. In this one, in this time, it took about 10 seconds before the thing went on, and I had long finished pouring in the water before it popped on. Okay, you can come downstairs and watch the live video, the real video, okay? Now, these guys don't claim to have...
How many seconds?
About 10 seconds, okay? These guys don't claim to need a Grama, or that's the reason. They wouldn't let you add water like this, okay? They only say add water when you push the buttons the right way, and it's essentially into a Shabbos mode. In that case, they don't need this delay. But it was just ironic that they had a delay. Okay, that they who had their own reason to be able to have the delay.
It's got to do the difference in the temperature of water, how good the thermostat is, how quickly it senses the change in the temperature to switch on.
That's correct. It's just ironic that they're the ones who weren't trying to make the delay.
This delay that they claim to have, 2 second delay, I don't know.
He says it's on purpose. No, the person who makes this machine says that it was on purpose. They told him to make delay. When I told him that it's so quick, he says, we'll rework it. Okay, but in his mind, it was a purpose. Now, I have to tell you something. If you do want to add water on it, okay, there is a way to do it. We had this thought. My son told me his yeshiva, they had the same idea. The Bachram desperately needed coffee on Rosh Hashanah, and there wasn't going to be enough water for everybody. So what they did is, and this you could do in your house, which is they plugged in a Shabbos clock into the machine. Okay? They plugged in a Shabbos clock that for a certain amount of time of the day, let's say from 7 to 8 o'clock in the morning, okay, the machine is off. And what will happen if you turn the if you make the Shabbos clock make the machine go off at 7 to 8 o'clock? What's going to happen is when it goes back on, first of all, it will have cooled off itself enough to set itself to go back on. That's automatic. It'll go back on by the time. And it happens to be the way the electronics work, it seems to me, is when you plug it in, it automatically goes on. It takes time before the sensor says, what's the temperature? Should I be on or not? Okay? I mean, even if the water is at a boiling temperature, it goes to boil itself no matter what, when it plugs itself back in. So if you set a clock, let's say that from every morning from 7 to 8 in the morning goes off. That means is at 8 o'clock, when the switch goes back on, it's going to go on anyhow. Then, before I go to shul in the morning, between 7 and 8, if that's when I'm going to shul, between 7 and 8 o'clock, I come downstairs, I can fill up as much water as I want to. At 8 o'clock, it's going to go on anyhow. The fact that I added more water to it means it'll stay up for longer. That, seemingly, everyone would agree should be Grama and should be okay. Okay, that's way unrelated. The amount that stays on, this and that is way unrelated. That would be mutter to do that. So that's actually the yeshiva. The whole yeshiva knew when the clock was going to say that the water was going to be out, and they were all standing there with their pitchers ready to fill it up again to make sure they have coffee for whatever the next day or the afternoon. But so you could do it on your own. You could take it home, plug any one of the machines, even the one like you have downstairs, plug it into a Shabbos clock, and then as long as you pay attention to when the time is going to be, the time when it's going to be off, then you're fine. At that time when it's off, you can add water to it.
Is there any difference between this and using those attached to the faucets, special hot water spigots?
I would think not.
Turn them on.
Okay, and his reason is?
His reason is it's not different in the refrigerator.
Okay, so the difference is, we can test it. I take it home and we try it. The difference is like this. In a refrigerator, when I open the door, of course it's cold air comes to the refrigerator. The effect that has opening the refrigerator on the refrigerator to go on is not a situation, and it's not clear it's not so direct for what I do to what goes on. The thermostat in a refrigerator usually is protected also. So I open the door, and the motor goes on, a lot of one leads to the other one. What you have to try with your sink one is, how direct is it? Let's say the thing holds 5 cups of water. Let's say it's what it is. If I take out 1 cup, will that make it go on? It may be that it's automatic, that when I take it out, it's automatic that it goes on because it's a temperature range. You know what I mean? If I get in that much cold water, it may go on. We try it. You take on the meter and put it on your thing and see what happens. You'll see in a second.
He said it used to somebody taking out 1 cup out of the thing. The person comes takes 1 cup of water. It's not a secretion.
Well, so you have to try it. It's not a matter of.
If you just tried it with 1 cup of this, if the water was hot in there, and you put in 1 cup.
It's possible. It's possible if you add just 1 cup, you won't get it on. That's true. It depends on what's there. Right. So it depends on how you did that. Okay. Psic ratio is a little bit of a dangerous thing over here, and I'll tell you why. Okay, to say psic ratio is not the greatest thing to say here, and that's because psic ratio is step 2 of Einem Miskaven. First you have to say I was Einem Miskaven. If I'm Einem Miskaven, it depends if I'm psic ratio or not psic ratio. Right? First I have to be Einem Miskaven. It's mutter because it's Einem Miskaven. Oh, but it's psic ratio, then it's usher. Well, am I Einem Miskaven if I take out water out of my hot water thing? Am I Einem Miskaven for it to get heated up? Or do I most definitely want that new water to get heated up?
Yeah, but say, right now I just want hot water. Right now this guy's coming from hot water. That's an advantage you can say to this. If somebody's adding hot water to this, you can say, putting hot water, I want to cook it up.
Hot water,
put cold water.
Right. But over there it's automatic. Over there...
So you think that's Einem Miskaven?
Yeah. Okay. Yeah, I'm sure. We
asked Rebelsky about the one, not for that, for a different situation like that, and he thought that was Miskaven. Because I don't just want my water now. I want to have water for tomorrow also. I want to have water an hour from now.
That's true. Right now I want water.
Okay, I guess you could debate that. He thought that was Miskaven, that I want the water to come in. You could debate that. But that's the first step. If you say that it's Einem Miskaven, then we could go to secret. But then whether it's secret or not, you could just test it. Okay, or you could say next to it, listen to it if you want to.
So that's a clear difference. So taking water from those things is much, much better than this.
It's better if it's not automatic and it happens, then right. Then
that's Einem Miskaven. This is Miskaven.
This is Miskaven, yes. Correct. Okay, I put in water. Why am I putting in water? Not for fun. I'm putting in water because I want it to heat up. Okay. So the refrigerator is a whole step down from that because it's not for sure. It's not for sure that's going to happen well by the, Einem Miskaven side, the psic ratio, misasik, I'm trying to take out an apple, I'm not trying to heat up my refrigerator, all those things that are going on, lots that plays into there, which is very different than these, where, again, you're right, if you're putting 1 cup, you may be okay, and we've been trying ideas of how to add water on Yom Tov. better than the Shabbos cloud. There are other ideas that have been brewing that we may be able to get away with. But the way it stands now, we don't see that you can get away with it. And we're working on trying to let people know about it.
So there's